Today my guest is Chris Risner. Chris, how are you?
I'm doing well, David. How are you doing?
Excellent.
Awesome.
I'm here at Code Mesh. I'm having a blast.
As am I. It's a great conference.
What do you do?
So I am a technical evangelist for Microsoft, and I focus on Azure, and inside of that, I primarily focus on mobile connectivity. And typically that is a lot of iOS and Android connectivity into Azure, but I do put a whole gamut, Azure in general, and then just iOS, Android, Windows Phone, everything.
Okay, when you say Azure and you say iOS and Android, I immediately think mobile services.
Absolutely. I mean, that's kind of, I would say that the first thing that Azure really had great support for iOS and Android was mobile services. It's expanded beyond that now, but mobile services is really kind of like, hey, if you're building an iOS and Android, this is the easiest thing to start using as far as Azure goes.
Cool. And you were described to be a new feature of mobile service that I've not really, haven't really played with yet. This is what?
This is offline storage. So, if you go back to when mobile services was first released and the SDKs were released, everything was kind of depending on you always having a connection to the internet. If you weren't connected, you weren't able to send data up, you weren't able to pull data down, and there was really no good story. And offline is really actually a very complicated thing when it comes to mobile apps. And now mobile services has support for this offline scenario.
Okay, well, describe the offline scenario.
So the scenario is, I'm building a mobile application, and either users inevitably are going to have times when they're going to use the app and they don't have a good network connection. Maybe the cell signal's bad, maybe they're not on Wi-Fi. Maybe they have to deal with the fact that they don't have a lot of data bandwidth in their plan, right? They don't want to waste this on all their applications. They want to use as little data as possible. These are all scenarios where having a situation where your application is capable of working offline is really important.
Okay, this is what they call the occasionally connected system.
Exactly, occasionally connected, or frequently offline even.
Yeah, or some people think of it as graceful degradation.
Yeah.
I make this app that just runs absolutely awesome when I'm connected. I don't want it to just crash when I'm not connected.
Right, and the thing is that when you're using the app, the idea is that you should be able to save new data, make changes, even if you're not connected.
Right.
And then back, when you get connected again, they just transparently is saved or updated to your backend system.
Okay, so how does mobile services help you now that it didn't used to?
So essentially what happened is a little while back, we released beta versions of all of our SDKs that had support for offline. I'll talk more about how that kind of works in a second. And at this point, though, we GA'd or made generally available the .NET, the managed SDK with offline support. So if you're building a Windows Phone application,
okay,
or a Xamarin iOS, Xamarin Android application, the SDK has support for offline, and that is production ready. The native Android and native iOS one, we're still working on that. That should be ready soon. Or it
okay.
should be. There's a beta SDK that has it, but it should be actually generally available, part of the production SDK very soon. So the way this works, if you've used mobile services before, what you would do is you'd create your mobile service client, and then you use that client to instantiate or create a mobile services table, and you'd say, I'm accessing the to-do table. And then every time you do something against that table, behind the scenes, the mobile service SDK is going directly to mobile services, your mobile service, and saying, save my data, fetch the data, update the data, etc. So the way it works now is instead of doing that, you use a sync mobile service table, essentially. And now what happens is when you make changes, they're actually written against a local store. And in all of these situations, you're using SQLite.
SQLite, huh?
Yeah, everything's using SQLite here. So all these situations, it's running against a local store. And then you as a developer decide when you want to actually sync with the server. So in theory, what you probably want to do if you're building an application is you say, do I have a network connection? Do I want to give the user the option to say only update on Wi-Fi or to update all the time? But then you can say basically you call push a sync on your sync context,
okay,
and that will actually trigger pushing the data up. And then you call pull a sync when you want to fetch data. And this also has support for getting incremental data changes. So let's say you want to pull all your to-do items.
Okay.
But you can either say just pull all the data, or you can say only pull the data since the last time I pulled data.
Okay.
So you're only getting the changes as opposed to all of the data again, which can save on bandwidth costs, which
right,
can affect cell or data plans, stuff like that. But there's support for that in there.
Okay. Now, one of the ways I like to write my clients, I like to cheat. I like to go through. There's a wizard in the portal.
Yes.
And is that code in there? that you just described, or how much of it?
So like I said, right now the managed client, the managed SDK is GA. So if you pull down the Windows Phone Quick Starts, or the Xamarin iOS, Xamarin Android Quick Starts, that code
generated code from the Azure portal.
Yes, exactly. That to do Quick Start application.
Yes, okay.
The code's gonna be in there. Now the interesting thing is that for iOS, for Xamarin iOS and Xamarin Android, that's going to be the code. If you run the app immediately, you're using offline code. But if you actually download the Windows Phone Quick Start, the code to do the offline stuff is actually commented out. And the reason for that is that it relies upon an additional installation of SQLite. So you have to proactively say, yes, I want to install this as well. So that's why that code is coming out. So essentially what you would do is you'd say, once you pull down that Quick Start, you would then install the SQLite VisX, or VSIX rather.
Okay.
And then once you have that, you can basically uncomment the offline code.
So this is something you just have to know to do.
Essentially right now that's correct.
Okay.
At some point I imagine it'll just be standard and you always have SQLite. For now it's just something you have to additionally install.
Okay.
Now when it comes to iOS and Android, those SDKs are beta, so if you pull down the Quick Start, the code won't be there. But there's a beta SDK you can go grab, and there's a beta Quick Start tutorial you can go through. But once those go GA as well, that's stuff that's already there on iOS and Android, so it'll be just built into the SDK. You don't have to worry about, it'll be built into the Quick Start. You don't have to worry about uncommenting it.
Okay. So there's that phrase, sync async or push async, pull async.
Yes.
And I think if we're doing this less frequently, it seems like there's going to be more risk of data collisions. People updating that same record that I want to update.
Exactly right. So the more frequently you actually update the data, the more frequently you update and then pull the data, the less frequently you have collisions. Now it's really important though, because you as a developer really do need to have an idea of what you're going to do if there's a collision. So let's say you have a client and I have a client, we're dealing with the same data. You update that data and then I try to update that data. My client is going to get an error back because I tried to update data that wasn't the most recent. It wasn't what you'd already pushed. It was old data. So my client will get an error back, in the SDK, and essentially it'll be this push error that says, hey, there was an error when we tried to sync the data up. This is what the situation was. This is what the data you tried to send was. This is what the current data is. This is what the old data is. What do you want to do? So from a developer perspective, you have that capability then to either show something to the user and say, hey, there was an issue with the data. Do you want to override or not? Or you can just dictate that you always want to overwrite, or that you just want to say, hey, there was an error. Here's the latest data. Try again. It's up to you to decide.
The scenario where you're showing them to the user sounds great if it's synchronous. But this is not only async, but it could happen when the user's not around. If you did something like only when you're get back on Wi-Fi.
You're absolutely right. And in that situation, you can always say something in the app store when they open it the next time. You say, hey, there was an issue. What do you want to do?
I see. Okay.
You could, depending on the operating system, you can actually pop something up in the UI even if the app isn't in the foreground. I know in Android that works. I think you can do that sort of thing in Windows Phone. I'm not sure about iOS.
There is toast in Windows, that's for sure.
Yeah, so you can exactly. So you can show toast even if the app isn't running in the foreground rather. So you have that capability to pop something up to say, hey, there was an issue. Do you want to jump into the app to fix it? Or you can save that data and then when they reopen the app, you can show something.
Okay.
But as a developer, it's kind of on you to dictate, and that really gets into some of the complexity of this offline stuff because there really is no this is the way to handle it.
Right.
And that's why it's so complicated and why it took a little while for mobile services to get it, is that it's hard to pick out what is the right way to handle the problem.
Right. And a lot of it just depends on the business case.
Exactly.
Who the users are, what the data is.
Exactly. And that's why, it's not like mobile services, the SDK just says, oh, if there was an error, we're gonna do this. Because there's no way to pick the right answer for every app. So that's why it's on the developer to decide how to handle things.
Anything else we should have talked about that we have not?
I think that probably covers it. There's just the change from going to mobile service table to mobile service or sync mobile services table. There's the idea that you have a push sync and a pull sync. Developer needs to deal with conflicts. That's
most of this is pretty simple, pretty straightforward. Conflict resolution is by far the most complex. That's because I have to think.
Exactly. You really have to think about what is the business case and how do you want to handle things. Now, the nice thing about the .NET SDK is that very, very, very little changes from the pre-offline to the offline is essentially using different classes and then just this concept of pull and push to sync. When you get into the
it's just that web API class that's doing it.
Exactly. When you get to the iOS SDK, again, very, very similar, just different classes. The Android SDK is actually inherently very different because of the fact that you have to deal with the fact that maybe later on you're doing this. So typically with the Android SDK, as it is right now, everything is tied to the context, the UI context you're in. Whereas when you talk about doing future push, there's this background context. See if there's some way to then signal the UI. So the Android SDK is really the one that has the biggest changes in going from the current SDK to the offline support SDK.
That's it.
Yeah.
Are you running another stuff anywhere?
So not right now, but I actually have some plans to release a few blog posts about this on my site on chrisrisner.com.
Okay.
Another great source to understand more about the offline stuff is actually Scott Henselman has a video series on Channel 9 called Azure Fridays.
Yep.
He's done a lot of
stuff.
Yeah, exactly. He's done some stuff recently with Donna Melari from the mobile services team, all focused on offline. So those are really great resources to look at as well.
Chris, thanks a lot.
Hey, thank you for having me. I appreciate it. I'm happy we're here, and I'm happy we're able to do this. It's just really great to be here. I'm so happy to be at CodeMash and be doing technology and friends, because really when I'm at CodeMash, obviously this is all about technology, and everyone here everybody is friends. So this conference really embodies this series, which is all about technology and about friends. So thanks for having me.